what I'd like to do in this video is quickly just draw up an angle, an acute angle actually. We'll go for something like 45 degrees. I'd like to touch the line there. Let's go again. I'm happy with that just for now. All right, so that's roughly a 45 degree angle, right? So starting from the x-axis, working counterclockwise, 45 degrees, right? We'll just label that 45 degrees. Now I can easily write the coordinates of this point here because we know that it's, well, the cosine of 45 degrees and the sine of 45 degrees, right? Because in our previous video, we learned that the x-axis, how far along the x-axis is the cosine of the angle, and how far you have to go up is the sine of the angle. And we can easily evaluate these terms here, cosine of 45 degrees and the sine of 45 degrees, because we have our trusty table that we developed in previous lessons, right? We have a 30 degree, a 45 degree, and a 60 degree chart here. And just remember, these are all acute angles, right? Within the 90 degrees, and which is within the first quadrant here. So I can just look at my table and go, all right, well, the cosine of 45 degrees is 1 on root 2, and the sine of 45 degrees is also 1 on root 2. So the coordinate for this particular point here on our unit circle is 1 on root 2, 1 on root 2, right? So we can easily evaluate those values there with a table. Here's my point. What if we have a non-acute angle, right? Coming out to 135 degrees, something like that. Oh, that was a bit shocking. Let's try again. Yeah, what if we have a non-acute angle of 135 degrees? Where do we go? Well, we don't have a table, right? To just go and find, all right, what's the sine of 135 degrees? Oh, there is none here. So we need to use another strategy, and we're going to use this idea of a reference angle. And let me just go ahead and remove some of this work here, and then we can go ahead and talk about what reference angles are. We use reference angles to find the cosine and the sine of non-acute angles. Let's read that fine point here. Key idea number 1 is that the reference angle is the angle between the x-axis and the terminal line. The terminal line being this line here, the line that ended your angle. All right, that's the terminal line. And so the reference angle is between the nearest x-axis and that terminal line. So it's kind of like the leftover angle to the nearest part of the x-axis. So let's label this angle. Let's do a bit of a drop there. We know this angle is, and we'll call it 135 degrees. All right. If that's 135, well, what must be the size of the reference angle? And we can find that out by doing this, right? If we're in the second quadrant here, if our angle is in the second quadrant, it's a matter of doing this. 180 degrees, right? And we take away, let's zoom in here, we take away the reference angle, right? And if we take that away, if we start off with going to 180 and subtracting our reference angle, we will get to the angle that we're interested in. So what's the whole point of this? Well, the reference angle can be used, right? The reference angle can be used. I'm reading this key idea here. The reference angle, which we'll call beta, let me identify that here in the diagram. The reference angle can be used to find the angle theta when theta is not acute. So we have a non-acute angle here of 135 degrees. How do we do this? Well, let's start off by marking or labeling the coordinate of this point. I'm going to go ahead and use green. What is the coordinate of that point right there? Well, we can use our previous knowledge and the previous video that I uploaded, and that is by thinking about how far we had to go across and how far we have to go up to get to this point. Let's think about it. All right. So from here we go across cosine of this angle. Now, what is this angle here? Well, let's do some working out over here. In the second quadrant, it's just the reference angle is equal to 180 take away 135, which is our theta, okay? Let's put degrees here. And so our reference angle is 45 degrees, right? We know this to be true. So this angle, the size of this angle is 45. So let's go ahead and write it. So the cosine of 45 and the sine. I am making a mistake when I'm saying this. Think about what mistake I'm making. The cosine of 45 and the sine of 45. I am making one mistake when I'm saying that, and we'll uncover it in a moment when I'm writing this. So the cosine of 45 degrees and the sine of 45 degrees, right? So just to recap, that was how far we went across, and that was how far we went up to get to this point. Here's the point that I'm making about me making an error, and it's this. When I start from my origin, and I work my way across, I'm going left on my x-axis. I'm heading in the negative direction. So on my x-axis, I'm going negative, and so I need to make sure that my cosine of the angle is also negative. Now, I'm not making the sine negative because we're going up, and up is positive in the y direction, right, on the y-axis. So sine remains positive, okay? All right, so what I'm going to go ahead and do is think about this. This angle here that we know that the reference angle is 45, I'm going to go ahead and draw an actual 45-degree angle in the first quadrant. Why am I going to do this? Well, hopefully you'll see why in a second. All right. That's roughly 45. I'm happy with that. What are the coordinates for this point? Well, let me just draw a little thing here. How far do I have to go across? Well, if we know that this angle here is also 45, because we just said we'd make a 45-degree angle, then this must be cosine of 45 across and sine of 45 across. And think about this. I'm going in the positive direction here and the positive direction here. So the coordinates of this one are cosine of 45 degrees and sine of 45 degrees. Can you see now the size of this angle? We can replicate it by putting it into the first quadrant. And the beauty of the first quadrant is that we know the cosine and the sine of 45 degrees. So what's my point here? My point is this. The cosine and the sine of this angle here of my 135 degrees, right? Can you see it? The cosine and the sine of this angle is the same as the cosine and the sine of this angle. They are identical because we went ahead and took the size of this and we put it over here, right, with this point here, and look, the cosine and the sine, excluding whether one's negative or positive, right, but they are exactly the same. So we know that the reference angle, beta, the sine and the cosine are equal in part to the cosine and the sine of theta, the angle that we were interested in the first place, which was right here. So let's go ahead and make some notes here, right? Let's consolidate. So when we're in the second quadrant, right, let's go ahead and make this formalized. So in the second quadrant, the sine, let me use blue, I'll zoom in just a little bit. The sine of an angle is equal to the sine of your reference angle. So the sine of 135, how far you have to go up, which is here, is exactly the same as how far you have to go up to get your reference angle, right? And we put that reference angle, we just moved it over here into the first quadrant, and you have to go up the same as the other angle that we just looked at. They're the same. So the sine of your angle, which we had 135, is the same as the sine of 45. That was our example. Now, it's slightly different when we look at the cosine. When you look at the cosine of the angle, have a look. The cosine, how far you have to go across, right? How far you have to go across to get to this angle it's equal to the negative, right? The negative cosine of the reference angle. Because the reference angle here, we had to go into the negative x-axis, right? So going around to get to 135, our reference angle, we had to go left, right? So that's why we call it the negative cosine. So essentially, the cosine of 135 is the negative cosine of 45 because we had to go left, right? We're going backwards on the x-axis. Now, we can use this idea to make the tangent. We haven't talked a lot about the tangent, but the tangent of an angle, well, if we think about it, the tangent is the sine divided by the cosine, right? And so sine divided by cosine, we have a positive divided by a negative, and so the tan of an angle will be equal to the negative tan of your reference angle, okay? That's our second quadrant. Let's go ahead and what I'll do is I might resize this and I'll put this, say, here, all right? Now, let's think about what happens. Before we do this, let's just think about how we find the reference angle, which we've already done, but I want to formalize it, right? How do we find the reference angle? Well, in the second quadrant, it's just, if we have an angle that that lands us into the second quadrant, it's just 180 minus the angle that we're interested in, and that'll get us our reference angle. So if we know our angle is 135, it's 180 minus that 135. That'll give us the remaining angle here, our reference angle. So let's just put a little note here. Right, you can find beta by 180 minus theta, and that'll give you your reference angle. That's for the second quadrant. Now, what happens if we're in the third quadrant? Well, let's write a little table here. Third quadrant. What happens in the third quadrant? Okay, let's think about it then, and we'll draw another angle. In the third quadrant, we're interested in finding out what this angle is. Let's use a laser, just for now. So from here all the way around, right? Well, what's that? Can we think about what that might be? It would be 180 plus another 45. So what's 180 plus 45? 225. Happy with that? We'll go with 225. So if that's 225 degrees, I'm going to label it, and I'm going to use a different color here. So let's go with orange. That there can be, we'll label it as 225 degrees. Okay. How do we find that angle? What's the sine and the cosine of that angle? Well, let's start off by writing in blue underneath our table to find the sine of that angle, to find the cosine of that angle, and to find the tangent of that angle, right? We know that we can use the reference angle. Well, let's think about it. All right, so to go all the way around, right, to find out what the reference angle is, which is this, right, the distance between the terminal line and the x-axis, it's just a matter of doing 180, let me start again, 180, sorry, let's think about it. The angle that we're interested in, which is 225, the angle minus 180, and that will give us the reference angle here, right? So the angle minus 180 will give us what's left over, and that's how we find our reference angle in the third quadrant, okay? So what will this look like? Well, let's just locate the coordinates. I'm going to use green here. What are the coordinates of this point? What are the coordinates? Okay, let's think about it. We go across... we're going backwards, right, for cosine. So it'll be negative cosine theta. And we're going down for sine. So both will be negative, right? Let's do that again. Negative cosine theta, negative sine theta. Let's write the coordinates. Negative cosine, and this angle here, what are we doing? We're doing, let's think about it. We're going across the same size, right? The negative cosine of 45 and the sine or negative sine of 45. Negative sine of 45, right? And we're really only looking at this angle here, right? This. If we were doing this entire thing, well, it would be negative cosine of 225 and the negative sine of 225. But we're just looking at this angle here, right? And so if we're just looking at that angle, have a look. It's equal to the other coordinates that we had, right? They're all the same. And so from there, we can establish that, and I'll write in blue, for our third quadrant, the sine of any angle in the third quadrant is equal to the negative sine of the reference angle. Now, how do we work out the reference angle? I explained before, and I'll do it again. It is that, right, theta, the angle that we know is 225, take away 180, and that'll leave us this gap here, okay? So it's reference angle is equal to theta minus 180. It's kind of like reverse to your second quadrant, where your second quadrant was 180 minus theta. Here it's theta minus 180. And let's keep going, finishing this table. The cosine of theta is equal to the negative cosine of your reference angle. Now, with the tangent is, remember, your sine divided by your cosine, and because both are negative, two negatives divided together will make a positive. So your tangent of your angle will be equal to the tangent of your reference angle, not the negative tan, all right? That's the third quadrant, right? Now let's do the last one, the fourth quadrant. Fourth quadrant. Okay. If we go into our fourth quadrant, right, in here, what would the size of that angle be? If we went around all the way, we could easily do this. It would be 360, right? 360 minus that little bit there. And if we went around all the way around here, and we chose to do this angle, we could estimate that to be 45. So it'd be 360 take 45, right? And we can do a little sum here. 360 take 45. Where would we end up, right? Well, let's do some working out. 5, 1, 3. That would be 315 degrees. Okay. So let's go ahead and make a 315 degree angle, and let's do that. Oh, that wasn't my straight edge, but it was still pretty straight, wasn't it? There, I'm happy with that. Now, if we talk about the size of the reference angle of this angle, it's simply the distance from the terminal line to the nearest x-axis there, right? Right there. Now, if we were to go ahead and label the angle, just the size of that angle there, from right here, it would be, let's think about it, how far do we have to go across our x-axis? We're going in the positive direction here, aren't we? So it's positive cosine theta, but we have to go down for sine theta, so that would make it negative sine theta. So cosine of 45 degrees, negative sine 45 degrees. Okay, that's the reference angle there. Now, how do we find the reference angle here? How do we find this? Well, it's ready. It's going all the way around. Take away your actual angle that you know. See that? If you go around the complete circle, 360, and you take away theta, it leaves you with this. I'll do it again. To find out what this angle is, it's the angle that you were given that lands in your third quadrant, and you take that away from, right? You take that away from a full circle, leaving you this gap, okay? So let's go ahead and write in the fourth quadrant, what would you get? So starting with the sine of theta, the sine of that angle would be equal to the negative sine of your reference because we're going down in that fourth quadrant. Well, that would be the sine of beta. The cosine of your angle would just be equal to the cosine of the reference angle because you're traveling positive along this x-axis, right, to get to that coordinate. And then the tangent of the angle would be equal to, well, it's a negative divided by a positive, and that would be the negative tangent of the reference angle. And how do you find the reference angle in the fourth quadrant? Like we just said, to find the reference angle, you take away theta from 360 degrees, and that'll give you your reference angle. And then we know that those reference angles, the sine and the cosine of those reference angles, are equal to the sine and the cosine of the angle that you were given. From there, all of these reference angles that we find, they will always be acute, the angles. So we can go ahead and use these and go to our table that we used to find out the sine and the cosine and the tangent of those angles. That's the power of the reference angle. In our next video, we'll actually take a look at some examples in all four quadrants.